Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Blind Date by Ulrhyme, and here are the rules. Standard Sudoku rules apply, where each digit 1 through 9 appears exactly once in each row, column, and 3 by 3 region. Also, in cages, digits do not repeat and sum to a value that must be deduced. Each cage shares a side with exactly one other cage with the same sum. So, for example, if this were, say this added up to 12 here, this would have to share a side with another cage that adds up to 12. Well, the only cages that are possible would be here or here, if that's the case. But it would share a sum with that same, with one of those cages. And those are all the rules. Again, you can't have repeats in cages. And the value that the digits in that cage sum to must be the same as exactly one other cage with the same sum. So you cannot have more than one. You can't have less than one cage that it shares a side with that would have the same sum. So I guess these, well, okay, that gets more into solving. But anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so what I was going to say is that every cage essentially is paired with another cage. And you know that because you can only have the same sum as only exactly one single cage that it shares a side with. So that's why it's probably this is blind date, because first of all, we're blind into what the sums are, but each cage has a pair with it, another cage that pairs with it, and those are all dates. So these are all essentially blind dates in a sense. Um, the interesting thing then is we can start marking these as pairs here, right? Well, what can single digits add up to? They can only be paired with cages that are 3 cells or less, because again, you can't have repeats. So this cage cannot be paired with these. So these two must be paired together and must add up to the same amount. Same with this one. This one cannot pair with this one because that's 10 at least. This is 15 at least, and so therefore this must pair with this one. This pairs with one of these two. We're not sure which. This single cell cannot pair with this. I can't be paired with the other single cell because then they would both be the same digit. So this must pair with this triplet. This must pair with this triplet. Let's make that pink. This single cannot pair with 1, 2, 3, 4, 5, 6, 7 digits there. So this must pair with the 2. We're going to mark that as orange. Therefore, this pairs... this is interesting here. So this 5 set must pair with one of these two. But it... Interesting. This 6 set must pair with this 4 because that's the only cage left. So we're going to mark that as pink. Let's not mark it as pink. Let's mark that as blue. So these must be the same. This then must pair with a 2. So it's either here or here. This can only pair with this. So this is those two. This then can only pair with that. So it's those two. These two must pair with these 5. So we're going to make that green. This then, if it pairs with this cage, it cannot. This cage doesn't have a pair to go with it. So this cage must pair specifically with that one. This cage must pair with this. Make that blue. And these two must pair then, because this has to pair with either this one or this one, and this one's the only one left over. So this is green, and these could be some sort of pair here. Interesting. Okay. This pairs, these two digits pair with 3 cell cages. So these add up to, these must be the sum of 3 unique other digits. So this is 6, 7, 8, 9. This pairs, okay, so if this were 15, so these are the same sum here. That means this is at minimum 15, this is at maximum 17. So either they sum to 15, 16, or 17. But if this sum to 15 and this sum to 15, what does that leave the rest of the box? It leaves the rest of the box as 15. And again, remember, these cages can only share a side with exactly one other cage with the same sum. So this cannot be 15 here. This is either 16 or 17, which means this has to be 9 with 7 or 9 with 8. Either way, this can't be 9 here, right? So 9 has to be one of these two digits. This then is either, if it's 16, it's specifically 1, 2, 3, 4, 6. Oh, that's interesting. So if this is 16, this is 1, 2, 3, 4, 6. This is 16 and this is 13. Okay, that's fine. If this is 17, this is 17 and this is 11. So it could be 1, 2, 3, 4, 7. Or 1, 2, 3. Okay. Right. 1, 2, 3, 4, 7. Or 1, 2, 3, 5, 6. So if this is 1, 2, 3, 4, 6 here, this must be 7, 9, and this must be 5, 8 here. If this is 1, 2, 3, 4, 7, this becomes 8, 9, and this is 5, 6. If this is 1, 2, 3, 5, 6, this is 8, 9, and this is 4, 7. So those are the possibilities there. This adds up to the same as this one. So this is 1 through 5, and 1 has to be there. These are 1 through 6, but 1 cannot be here. So this is 2 through 6 here. This would have to be either 1 or 2, 3, or 4, right? If it's either 1, 2, 6 adding up to 9 possibly, or it could be 1, 3, 5, or it's 2, 3, 4, or it could be like 1, 2, 3, 1, 3, 4. Actually, it can't be 1, 2, 3 here. This is at least a 1. It could have 1, 2, and 3 here. Okay. This is again at least 15. This is at least 15. That's all we know. So this is 1 through 7. This is again 1 through 7. But 1 through 3 cannot be in the rest of this row. This adds up to at least 16. Sorry, 15. So this is at least 6, 7, 8, 9. This cannot be 1, 2, or 3. So this is 4 through 9 here. This is 6 through 9 because it must have 3 digits adding up to it. So this is 1 through 6 here. Oh, interesting. Oh yeah, this is at least 15. So this is 1 through 7, which makes this 6 through 9 because it's at least 15 here. This is at most 17, sorry. So this is interesting. This is either 13, which adds up to this, or it's 11. Either way, this has to be 2, 3, 4, 5, 6, 7, 8, 9. But we know 8 and 9 cannot be here because these, where is the 8 and 9 in row 6? Can't be any of these because this is 7 at most. Can't be any of these because this is 6 at most. So 8 and 9 all in row 6 has to be in box 5, which eliminates 8 and 9 in the rest of the box. Therefore, this can, if it's 13, it's 6 and 7. That's interesting. If it's, so if this is 13, it has to be 6 and 7. If it's 11, it's 4, 7, or 5, 6. Interesting. Well, if this is 13, the only way this is 13 is if this is 16, right? You have 16, 16, that adds up to 32. 45 minus 32 is 13. So if this is 16, that makes this a 6, 7, which means 7 can never be here. This is 8 or 9. Okay. What does that mean? I'm not sure. Okay, what is this? Is kind of a question. This is 1, 2, 3, 4, 5, 6, 7. So this is at least 28 because 1 through 7 adds up to 28. This is at maximum 30. Interesting. So this is at least 28. It cannot be 30 because that would eliminate all possibilities for this cell because 30 requires 4 digits. If it requires 4 digits, it's 6, 7, 8, 9, and that eliminates all possibilities here. So this is either 28 or 29. Because of that, we know this has to be then either 4, 7, 8, 9. This is 28 or 29. Okay, that's interesting. So these must be the digits 1 through 6, and then we have a 7 or 8 here. Huh. These digits, again, can be either 5, 7, 8, 9, in which case this is 6. So that's interesting. So if this is 5, 7, 8, 9, this has to be a 6. This is then 1, 2, and 3, and this must be a 4. Or it could be 4, 7, 8, 9. This is still a 6. This is 1, 2, 3, and this is 5. Or it could be 5, 6, 8, 9. In which case this is a 7. This would then be 1, 2, 4, and this would be a 3. Either way, one of these... Okay, so this cannot be a 6, 7, 6, 7 pair because that would eliminate all possibilities for this cell. Therefore, this is 11 exactly, which means this is 11. So this cannot be an 8 here. This is 11, which means these two cages add up to 45 minus 11, which is 34. Therefore, 34 divided by 2 is 17. This must be an 8, 9 pair, which means this can't be 8. Therefore, 1 and 2 are here, which means 2 cannot be here. So this is 1 or 2 here. And this must be a 9 here. Because if this is not 9, say this was a 6. If the 6, this would have to have 1, 2, and 3 be in this cage, but 1 and 2 cannot be here. If this is 7, it would have to have 1, 2, 4 in that cage, but 1 and 2 cannot be here, and therefore you would have 2 digits in one cell, which is not allowed. If you have 8, I guess it could be 8. So this could be 7, 8, or 9 specifically. It could be 1, 3, 4. It cannot be 1, 2, 6 anymore. So it's either 1, 3, 4, 1, 3, 5, or 2, 3, 4. Either way, the 3 is here, which means this cannot be 3 here. This has to be 1, 2, and 4, adding up to 7. So this is 7. 1, 2, 4. This can't be 4 here. This has to be a 3, 5 pair, which makes this a 1 and this a 9. right? Because 3 and 5 add up to, at minimum, 8. This can't be 7 or 9. This cannot be 7, 9, or 5, or 4. This is a 6, 8, 6, 8 pair, which eliminates 6 and 8 in the rest of the column. So this can't be 5 or 6, because that adds up to, this has to be 4 and 7, which means the rest of this cage cannot contain a 4, or the rest of this box cannot contain a 4 or 7. This is 4 or 7, so this can't be 4 or 7, which forces this to be 5 or 6. This 5 or 6 means this can't be 5 or 6, so this is 7, which means this has to be 5, 6, 8, 9. So this adds up to 28, which means this adds up to 28, so it has to be 1 through 7. But this can't be 7 here. This 5, 6, 8, 9, this has to be 1, 2, and 4, adding up to 7. That eliminates 1, 2, and 4 in the rest of the column, so this can't be 1 or 2. This 3, 5, 6 triplet eliminates 3, 5, and 6 in the rest of the box and the rest of the row. I said column, didn't I? This 1, 2, 4 means this can't be 4 or 5. This has to be a 3, which means this can't be 3 in the rest of this cage. This can't be 6. This has to be a 7, 8, 9 triplet here. This can't be 3, 5, or 6 because of the 3, 5, 6 triplet in its box, so it's a 1, 2 pair, which eliminates 1 and 2 in the rest of the column. This can't be 1 or 2. This must be a 4, which means this can't be 4. So this is a 1, 2 pair here. This can't be 6 because of the 6, 8 pair in the column. We also have a 3, 5 pair in column 3, which leaves the only possible digits in column 3 to be 1, 2, and 9. This can't be 5 or 6 anymore. This can't be 7. This can't be 5 or 6. This can't be 7, so this must be 4, which makes that a 7. This can't be 4, and these can't be 7. Oops, 7. So this is 1, 2, 3, 4. That adds up to 10. And we don't know what the last one is. So no 1, 2, or 4 here. Could be 5, and this was 7, 8. Could be 6, and this is 8. This is 8, 7, 9. And it could be 7, and this is 8, 9. We know where the 3 has to be. It has to be here. This is 3, because there's no other place for it in box 5. This can't be 1, but we know we need a 1, so one of these is a 1. This can't be 7 anymore. So it's either, well, it could be many things right now. Well, we have a 6, 8, 6, 8 pair in row 7, which eliminates 6 and 8 in the rest of the row. Therefore, this is adding up to 15, because it's the digits 1 through 5 here. Therefore, this adds up to 15, so it can't be 6 or 8 here. This is 7 or 9. One of these is 8 or 9, and this is an 8 or 9, so that eliminates 8 and 9 in the rest of the column. So this can't be 8 or 9 here. This is 6 or 8. These... Okay, so... we know for certain one of these digits has to be a digit here. Because you have the digits 1 through 7 in that cage, adding up to 28. And therefore, and you have 2 digits adding up to another digit here. You have an 8 and a 9 here, essentially. So this must be 8 or 9. Because if it's not 8 or 9, where are the other 8s and 9 possible? This can't be 8 or 9 because this is less than 8 or 9. Therefore, both 8 and 9 would have to be in that cell, which is not allowed. So this is specifically 8 or 9 here. These 2 digits add up to what that digit is. Oh, that's interesting. Okay. So these 2 digits add up to the same value. So it's 2 times a number. These 2 digit cell cages add up to the same number. So it's 2 times another cage. So this is even. This is even. This is even. To add up to an odd digit, which is what 45 is, you need, and if they're all evens, you need an odd digit. So this is odd. This is 1, this is 2. Actually, we knew that from there anyways. Okay. The remaining digits in row 8 are 4, 6, 7, 8, 9. Okay. 1 has to be here. So this cannot be 3. Oh, well, it couldn't be 3 anyways. It could be 4. It could be 5. And this is 2 and 3. That is potentially possible. This can't be 7 because of this 7. Okay. Okay, so this cannot be 14 and 14 here. Well, actually, it could be. No, it can't be. If it's 14 and 14, um, this is at least 5. It could be, it can't be 6 because that would require 1, 4 or 2, 1, 5 or 2, 4 here. And they're both eliminated by this 1 and 4. It could be, so if it's 5, this has to be 2, 3. If this is 7, it has to be 2, 5. If it's 8, it could be 2, 6 or 3, 5. So that could work. No, hold up. If it's 8, this becomes 6, so then it would have to be 3, 5. Oh, this is interesting. And if it's 9, it could be 2, 7, 3, 6, or 2, 6 or 3, 7. Sorry, 2, 7 or 3, 6. But if it's 9 here, this would have to be 7, 8. Okay, so if it's 5, it's 2, 3. If it's 7, it's 2, 5. If this is 8, this would have to be 6. So it would have to be 3, 5. And if it's 9 here, this would be 7, 8. It could not be 4, 5. It would have to be 3 and 6, if that were the case. Interesting. This can't be 3 here. What are the remaining digits in column 1? They're 3, 5, 6, 4. 3, 4, 5, 6. How about the remaining digits in column 2? 3, 5, 6, 7, 8. Interesting. Ah, this is 15. So this cannot be 15. So this cannot be 15 then. So it can't be 5. It's either 6 or 7. This is 16 or 17, so the 9 cannot be here. This can't be 1. What's the minimum here? This is 2 and 4 at least. So this is at least 6. So we have 6 through 9 there. If it's 6, this has to be 2 and 4. If this is 7, it has to be 2 and 5. If it's 8, it has to be 2 and 6. If it's 9, it could be 2, 7, or 4, 5 here. So either way, if this is 6, 7, or 8, this has to contain a 2. Therefore, there can't be a 2 in any of the rest of the column. Or if this is 9, this could be 2, 7 or 4, 5. If this is 4, 5, that would force this to be 2, which means there cannot be a 2 in the rest of the column either way. So this must be 4 through 9. This must be 4 through 9, but this can't be 4. Again, this can't add up to 14. Again, if you have 6 and 8, 6 and 8, that makes this 5 and 9. This would be 7 and 2 and 3, which doesn't add up together. So this cannot be 6 and 8 specifically. I guess this could be 15, right? 6 and 9, 7 and 8, which would force that to be 5, 2, 3. That works. What else is possible? It cannot be 8 and 9 here. What about, okay, the other possibilities? Seven's one of these three. If this is 7, this is 2 and 5. So we'd have to have... Huh, does that even work? If this is 7, again, this is 2 and 5. We have the remaining digits 3, 6, 8, and 9. But those don't add up to each other. So this can never be 7 then. 5 works. This can't be... I think we had... Didn't we have a 9 here? Why can't that be 9? If this is 9, 3, 6... Oh, well, that can't add up to each other. Okay, so there are some issues. Okay, so if this is 5, this is 2, 3, and this is 6, 7, 8, 9, and that works fine. If this is 8, this has to be 3 and 5, because it cannot... If this is 8, this is 6, 9 here, so it cannot be 2, 6. So if this is 8, this is 3, 5, which makes this 6 and 7, but then you have 2 and 9 here, and those don't add up together. So 8 doesn't work. If you have 9 here, this is 7, 8, which forces this to be 3 and 6. So 9, 3, 6, which makes this 8 and 5 at minimum, and this would be 2 and 7, which doesn't add up to it. So this cannot be 9. This has to be 5, which makes this 2 and 3. This is now a 6, 7, 8, 9 quadruplet, which add up to each other. It's 15. Which leaves, this cannot be 7 or 9. This cannot be 2, 3, or 5, which means this is a 1, 4 pair here. That eliminates 1 and 4 from the rest of the row. This cannot be 4, so this has to add up to 15 also, because this adds up to 15, and these are the remaining digits from 6, 7, 8, and 9. So this can't be 8, because if this is 8, this would have to be a 7 here. Okay. What can these digits be? If this is 8, this has to be 1 and 7, or 2 and 6. If this is 9, this has to be 1 and 8, or 2 and 7. It cannot be 3, 6, or 4, 5. Interesting. So because of that, we know 1 of 1 or 2 cannot be in this box, so it must be here. So one of these is 1 or 2, which means since one of these is 1 or 2 and this is 1 or 2, that eliminates 1 and 2 in the rest of column 6. So this can't be 1 or 2. This must be a 4. This can't be 4. This can't be 1 or 2, and this can't be 4. Well, where's the 4 now in row 8? It has to be here. So this is 4. These can't be 4, which requires then a 4 to be one of these cells. We're not sure which. So this, if this is 2, this has to be 5. Otherwise, or this is 4, 5, adding up to 9. And then this has to be 2, and this can't be 5. So either way, this can never be 5. So this is 6, which makes that a 5. This can't be 5. There can't be any more 5s in column 4. This can't be 6 either. So this is either 2, 4 adding up to 6, 2, 5 adding up to 7, or 2, 7 adding up to 9. You can never add up to 8 here anymore. We have a 6, 7, 8, and 9 quadruplet in column 5, which eliminates 6, 7, 8, and 9 from the rest of the column. Therefore, it can't be 4 or 5. This must be 1, 2, or 3. Okay. This is 2 or 5, 2 or 3, 3 or 5. We're not sure what this is. Okay. This can never be 1 and 2 added together because that adds up to 3, and there's no other 2-cell cage combination that can add up to 3. So this has to be a 9 here, which means this cannot be 9. So this is either 10 or 11. It cannot be 11 because we already have 11 that's sharing a side with it, and this is only 1. This has to share with that one specifically because this one doesn't have any other cage to share with. So this cannot be 1, 9. Sorry, cannot be 2, 9 because that would add up to 11. This must be then a 2, which means this can't be 2. None of these can be 2 here. This is 10. That's interesting. So one of these must add up to 10. So either this is 2, 8, and this is 3, 7. So whatever this is can never add up to 10. 28, 28. 15, 15. These are both 5. This is 15. This is 9, 9, 7, 7, 17, 17, 11, 11, 16 or 17, we're not sure. This is 7, 7, 8 or 9. The rest of the row Interesting. Where is 8 in row 1? Can't be here because of the 8, 9 pair. Can't be here because this cage must be essentially adding up to 28 with 7 digits. Can't be here or here because, again, this can't be 2 and 6 anymore, which is the only possible combination to add up to 8 here. And it can't be, there's no 1 and 8 adding up to 9. So it has to be here. So this is 2 and 8, which means these match. Therefore, these two match. Let's make that pink. These can't be 8 anymore. But this cannot add up to 10. So what are these combinations? It could be add up to 9. It can't add up to 8. So if we try 8, this would be 3 and 5, but then what would this be? There's no other combination of 8 that works. So either this is adding up to 9, which makes this a 3, 4, 5, 6, or it adds up to 11. If we try 12, that doesn't work. 5, 7 with what 2 pair digits without an 8 or a 9? Doesn't add up. So either this is a 3, 4, 5, 6, and this is 7. Oh, or this is 4, 7 with 5 and 6. And this is 3. So this is specifically 3 or 7 here, right? Either it's 3, 4, 5, 6, with both of them adding up to 9, and this is 7, or this is 4, 7, and this is 5, 6 here. Okay? Where is the 1 in row 1? Can't be any of these cells, can't be here. It must be one of these 4, which means the remaining digits in that cage cannot contain a 1. Okay. Okay, one of these is 1 or 2. Just guaranteed, because if you have an 8 or a 9 here, you need to have a 1 or 2 here. We have a 1, 2, 4 being possibly here, and a 1, 4 being possibly here. Also, this can't be 5 anymore because of this 5. Well, what does that mean? Since one of these is 1 or 2, this must be 1, 2, or 4, and this must be 1 or 4. These 3 cells, 3 of these cells must contain a 1, 2, and a 4, which eliminates 1, 2, and 4 in the rest of the column. So this can't be 1 or 4. This is 5, 6, or 7. Actually, where is the 9 in row 1? Can't be here because of this has to be a 1 through 7 cage. Can't be here because this must add up to that digit, and 9 can never add up to another digit with another digit to add up to a single digit. It can't be here because the 1-9 pair is here. So 9 has to be here, which means this can't be 9 and this can't be 9. This adds up to 15, so this can't be 6. This is 7 and 8. Where is the 9 now in row 6? It has to be here because this must add up to 16 or 17. Either way, actually, so this can't be 9 here, which makes this not a 6. Therefore, this is 15, and this 7, 8 pair eliminates 7 and 8 in the rest of the row. This must be a 9, this must be 6, this must be 8, which makes this a 6 and a 9. That makes this a 7 and an 8 here. That makes this a 6. This can no longer be 6 here. This is a 7, 8, 7, 8 pair, which eliminates 7 and 8 in the rest of the row or column. So this can't be 7. This is a 6. So this adds up to 16. This must add up to 16. So this is 7. This is 8. This is 8. This is 7. This can't be 8 or 9 here. This is 2 and 7 adding up together to add up to 9. Or it's 4 and 5 adding up to 9. So this can't be 7 here. This can't be 7 here. And this can't be 5. Or no, can't be 4. Okay. Well, one of these is 3 or 5 here. So we have a 1, 2, 3, 5 quadruplet in column 6, which eliminates 1, 2, 3, and 5 in the rest of the column, which makes this an 8. So this can no longer be 8. 8 has to be one of these 2 digits here. And this can't be 8, so this must be 9, which makes that an 8, and this must be a 1 then. Well, the 1 can no longer be in box 3 in this cage. Where is the 1 possible now? In this cage, it has to be here. So this is 1, which makes that 2, which makes that 1, which means this can't be 1, this can't be 2. This 3 or 5 has to be the same digit as that one because it's in this cage and we don't have 1, 8, or 9 anymore. This cannot be 9, so this is 8. None of these are 8, so 9 has to be, cannot be here. We have a 5, 6, 5, 6 pair in row 4, which eliminates 5 and 6 in the rest of the row. So this must be 9, which makes that 8, which makes that 9. This 1 means this can't be 1, so this is 2, which makes that 1. This 1 means this can't be 1, so this is 4, which makes that 1. This 1 and 4 means this can't be 1 or 4, so this is 2. This can't be 1 or 2, so this is 4, which makes that a 1. This 5 and 7 means this can't be 5 or 7, so this is 6, which means 6 cannot be here. This can't be 6 because of that 6, so this must be 5, which makes that a 6. None of these can be 5. So we know 4 and 7 have to be here in these 3 cells, so this can't be 4. This has to be a 3, 5 pair. Which eliminates 3 and 5 in the rest of the column. So this can't be 3. This must be a 2, which makes this a 3. So this 3 means this can't be 3. That's 3 in the corner. We celebrate because we know we're getting close to finishing. one of these must be a 3 in box 2. Because 3 can't be here, 3 can't be any of the filled-in digits, so this must be a 7. Which means this must add up to 9 here for these two cages. So this can't be 6. This has to be 4 and 5, adding up to 9, which makes this 3 and 6. That 3 and 6 eliminate pair. This can't be 6 because of that 6, so that must be 3, which makes that a 6. We celebrate because we're getting even closer to finishing. This can't be a 5 because this can't be 3 because of this 3, so this is 5, which makes this a 3. Therefore, this can't be 5 here in this cage, so this must be 3, which makes that a 2. This can no longer be 2, so this is a 4-5 pair, which eliminates 4 and 5 in the rest of the column. So this can't be 4, this must be 7, which makes this a 2 because it can't be 5. That makes this 3, which makes that 5. This 1 means this can't be 1, so this is 9, which makes that a 1. This can't be 4 or 7, so this is 2. This can't be 2 or 7, so that makes that 4, which makes that a 7. This 5 makes that not a 5, so that's a 4, that's a 5. This can't be 3 or 6, so this is 5, which makes that a 3. Therefore, that's a 5, which makes that a 3, and there's a 6. And that's how you solve it. Pretty cool, actually. Not too hard for me, but then I've done a ton of Killer Cage Sudokus, so I know a lot of these numbers by like heart, essentially, so it goes fairly quickly for me. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.